In section 3.4, we're going to talk about the slope and the rate of change in between points on a line. Slope is one of the most important characteristics of a line. You can tell a lot about a line if you know its slope. So we'll learn how to find the slope of a line if we're given 2 points. We'll learn how to find the slope of a line if you're given the equation of a line in a certain format. And then, of course, we need to know how to find the slopes for a horizontal and a vertical line. And then, how do slopes compare for parallel and perpendicular lines? And then, what is slope as it relates to a rate of change? So basically, the slope of a line is, you may have heard it called rise over run. What that means is, rise means how many up. That's your change in y. How many up? Run is going along the horizontal. That would be your change in x. That little triangle there, that's the Greek symbol delta, which means change. And so how many over? So the slope of a line is really how many up and how many over between 2 points on a line describes the slope of the line. Now, a positive slope or a line with a positive slope will increase as x gets larger. All right, so it's going to go up. It's going to increase if there is a positive slope. Down here, you'll see in our second example, here we have a line that's obviously decreasing as x gets larger. That would be a negative slope. So we don't know what the slope is here, but we do know it's going to be a positive number. The slope is a number. It's typically a fraction. How many up and how many over? How many up or how many over? For a negative slope, it's going to be how many down in the numerator and how many over in the denominator. The change in y would be negative. So let's just look at these 2 examples before we go to the examples from the book. If I have this point right here, and this is the point x is negative 2, y is negative 1, and I have a point over here, 1, 2, 3, this is the point x is 3, y is 1. How many up going from this point to this point would it be? 1, 2. I'm going up 2. And how many over is it? 1, 2, 3, 4, 5. So this is over 5. So the slope of this line would be 2/5. 2 up, 5 over, 2 up, 5 over. For any 2 points, up 2, 5 over, up 2, 5 over, up 2, 5 over. And we're actually going to give you a formula for calculating if you're given 2 points. You don't actually have to sit there with your pencil and count 1, 2, 3, 4, 1, 2, 3, 4. So the slope of this line is 2/5. Positive 2/5. That's a positive number. How about the slope of this line? Here we're expecting a negative slope, and so here I have the point negative 2, 1, 2, 3, 4, 5, negative 2, 5. And here I have another point. I'm just picking any points that actually fall right on a grid line, so we know they're a whole number. They're not falling in between, so that's a 1 and down 2. X is 1, y is negative 2. Well, how many down do I have to go to get from this point to this point? 1, 2, 3, 4, 5, 6, 7. I'm going down 7. And how many over? 1, 2, 3. Over 3. So we would say the slope of this line is down 7 and over 3. The slope of this line is negative 7/3. between any 2 points, it's down 7 over 3, down 7 over 3. So slope is a number describing the rise, how many up and over, or how many down and over. So you could put your points on a grid, and we'll actually do that and count the boxes just to make sure. But the equation for finding the slope of a line when you're given 2 points, they use the letter M to represent slope. That's the y value of the second point minus the y value of the first point over the x value of the second point minus the x value of the first point. This is the difference, which is subtraction, the difference in the y values over, and in the denominator, the difference or subtraction in the x values. So if I have the point negative 2, 3, and I have the point 4, negative 1, this is going to be x1, x for the first point, and this is y1, the y for the first point. This will be x2, the x value for the second point. This will be y2, the y value for the second point. So using our formula for slope, the slope of this line would be negative 1 minus 3. That's y2 minus y1. And in the denominator, I have x2, the x of the second point, minus x1. So negative 1 minus 3, that's negative 4 in my numerator. And this negative of a negative becomes positive. So 4 plus 2 is 6. And we would want to reduce that by 2. Negative 2/3. So I would say my slope is negative 2/3. Down 2 over 3, down 2 over 3, down 2 over 3. So I'm not going to be surprised when I plot these 2 points and create the line that it's going decreasing as x gets larger. Okay, so let's go ahead and graph this. Negative 2, 3, and 4, negative 1. Let's go ahead and draw that line going through those 2 points. We'll put the arrows on because lines go on. Okay, so how many down? 1, 2, 3, 4. So that's down 4. And over 1, 2, 3, 4, 5, 6. It is down 4 over 6. But let's try down 2 over 3. Down 2 over 3. Down 2 over 3. Between any 2 points, it'd be down 2 over 3. Down 2 over 3. So our picture here, our diagram, confirms that we did the correct calculation. All right, so you're going to go and do practice 1 for section 3-4. Practice 1. For classroom example 2, let's use our formula to find the slope of the line between these 2 points and then graph the line and confirm that we have the right slope. So the slope is y2 minus y1 over x2 minus x1. Here's x1, here's y1. Here's x2, here's y2. By the way, you could swap and make this the first point and that the second point. It will still work out correctly. So my slope is going to be 5 minus 1 in the numerator and 3 minus negative 2 in the denominator. And so in our numerator, 5 minus 1 is 4. And in the denominator, 3 plus 2 is 5. So this is a positive slope up 4 over 5, up 4 over 5. Let's plot the points and see if we're correct. We're going to plot negative 2, 1, and 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Hopefully you've got graph paper. The more precise you are, the easier these concepts are going to be to grasp and confirm. All right, that's what my line looks like going through the points negative 2, 1, and 3, 5. Now let's check. Up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Yep, it is up 4 over 5, up 4 over 5. Okay, go ahead and try practice 2. Moving on to example 3, we gave you the formula for how to calculate slope if you have 2 points. Now we want to introduce a new equation of a line, and this is called slope intercept form. Why is it called slope intercept form? It always starts with y equals, just one y equals m times x plus b. Why is it called slope intercept form? The coefficient in front of the x is the slope of the line, and b is the y value for the y-intercept, the intercept along the y-axis. So if you're given the equation of a line and it is in slope-intercept form, you'll immediately know where does it cross the y-axis and how many up and over is it. You'll have in your mind an idea of what the line looks like. So here, they want the slope and y-intercept of y equals 5/9 x plus 3. Well, this is in slope-intercept form, so the information we need is right in the equation. My slope is up 5 over 9, up 5 over 9. My slope is 5/9, up 5 over 9. And my y-intercept is at y equals 3. X is 0, y equals 3. So just if I'm given this equation, the first point you plot is the y-intercept. If my y-intercept was 3, the first point is always the point on the y-axis. And now I'm going to go up 5 over 9. 1, 2, 3, 4, 5. And then over 9. 1, 2, 3, 4, 5, 6, 7, 8. And kind of goes off my grid there, but we're going to deal with it. That's what the line y equals 5/9 x plus 3 looks like. Intercept the y-axis at 3, and to find the next point we went up 5 over 9. So you're going to try for yourself practice 3.